In this class, now I am going to discuss with you first part of probability. In this first part of probability, I will give you the introduction part of the probability. And for the second part, I take one more class in which I explain you addition theorem on probability, conditional probability, multiplication theorem on probability, Bayes theorem. So for the second part, I take one more class, but in this class, I am going to discuss with you introduction of probability. Now see that introduction part. So first, we would have to know the meaning of a random experiment. Name of the chapter is probability. Now let us see the first one, random experiment. Random experiment. See students, an experiment whose outcomes are already known to us, but while conducting the experiment, which outcome do we get exactly we cannot predict. So such kind of experiments are known as random experiments. For example, take a coin and throw upwards. So what do we get? Either we may get a tail or head. So if we throw a coin, as we know, whose outcomes, either we may get tail or head. But while throwing, we cannot predict the exact outcome. Yes or no? Like you can throw two coins. If you throw two coins on the topmost surfaces, we may get either head or tail or head, or both may be heads or both may be tails. Four possibilities are there. Like you can throw 3 coins or any number of coins. In the same way, take a dice, which looks like a cube, which has 6 surfaces. On the 6 surfaces, mark 6 numericals like 1, 2, 3, 4, 5, 6 and shuffle and throw on the floor. On the topmost surface, what number we may get from 1 to 6? We may get any one from 1 to 6. Like you can throw 2 dice or more than 2 dice. Like, so take the deck of cards, playing cards. So which has 52 cards. Now shuffle it well and pick a card from it. What do we get? We cannot predict exactly. So all this comes under random experiments. Many are there, just I am giving you few examples. Throwing single coin or 2 coins or 3 coins, or throwing a single dice or 2 dice or more than that, and picking a card from the given number of cards. So all these are examples for random experiments, because outcomes of that experiment, but while conducting the experiment you cannot predict exact outcome. So such kind of experiments are known as random experiments. Okay, right. Now you got the meaning of a random experiment. Now let us go to the meaning of a sample space, which is denoted by the letter S. Suppose if you throw a single coin, okay, what do we get on the topmost surface? Either we may get head or tail. You may get any one of these two. In the same manner, if you throw 2 coins on its surfaces, we may get 2 heads or 2 tails, or 1 head, 1 tail, or head tail. These are 4 possibilities. See, so this is the total number of outcomes of throwing a coin, where n represents number of coins. If you throw one coin, put n equal to 1, you get head tail. If you throw two coins, you will get four possibilities. Here put n equal to 2. 2 square 4. 4 possibilities will come. Like if you throw 3 coins, how many outcomes do we get? If you want to throw the 3 coins simultaneously, you can. Otherwise, you can throw one after the other. Okay. See, if you throw 3 coins, see, you get the sample space like this. Write 4 heads and 4 tails. And 2 heads, 2 tails. 2 heads, 2 tails. 1 head tail. 1 head tail. Head tail. Head tail. Like 8 possibilities. Put in a sample space. Okay, put in a set. So this is a sample space for 3 coins. When we go to the competitive exams, we make it n number of coins. Okay, students? Right. See, this is the sample space for throwing a single coin, 2 coins, 3 coins. See, if you go to the dice, which looks like a cube, which has 6 surfaces. On the 6 surfaces, mark 6 numericals. So we may get the sample space like this. 1, 2, 3, 4, 5, 6. If you throw 2 dice, see, write 1 dice there and one dice here. See, on this you may get 1, 2, 3, 4, 5, 6. On the second one, 1, 2, 3, 4, 5, 6. So if you throw 2 on the floor, on the topmost surface, you may get on this one and in this one. So 1, 1. So on the first one, 1 and second one, 2. 1, 2 you may get. Here on this 1 and on this 3. 1, 3. Like that. 1, 6. Now write here 2, 1. Here on this 2, in this 2. 2, 2. Here 2, here 3. 2, 3 and so on. Okay, students? Now, see, continue it. 6, 6, like this. Here 6. Total 6, 6 are 36 outcomes you will get. This is the sample space for 2 days. When we go to the competitive exam, we may get n number of dice. Okay, students. See. Now let us go to the description of cards. Deck of cards, playing cards, So that deck has, this deck has 52 cards, which divides into 4 shoots. In this probability chapter, we say them as shoots. So this is said to be, okay, spades and clubs, diamonds, hearts. So this 52 cards divides into 4 equal shoots. So each group will get 13 cards. Okay, students? Each group will get 13 cards. And if you see the back side of this spades, you get this kind of symbol like leaf. And if you say see the back side of this clubs, you will get this kind of symbol, and diamonds with this symbol, and hearts with this symbol. And the spades and clubs are there with black color, and the diamonds and hearts are there with red color. Suppose if you take any shoot, so that first card is an ace. If you take any shoot, any one of these four, first one is an ace, and from see 2 to 10, these are number cards from 2 to 10, and the last three are called Jack, Queen, King. So in every shoot you get 13 cards like this. First one is an ace, and from 2 to 10 number cards. On this there are numericals like 2, 3, 4, 5, 6, 7, 8, 9, 10, and the last three are Jack, Queen, King. Jack, Queen, King are human beings, no? So which has face, hence which are called face cards. What do we say them? Face cards. Like if you go to the second shoot, third shoot, fourth shoot, all will be like this only. So in the entire deck there are 4 aces and 3 4s are 12 face cards. So in every shoot there are 9 number cards. In the entire deck 9 4s are 36. 36 number cards are there. Based on this they generate the applications. I think we have got the meaning of sample space. Means outcome. Sample space means which contains outcomes of a random experiment. Now let us go to the meaning of an event. Event. Here in this chapter, event means subset of sample space. Event means what? Subset of sample space. Part of a sample space. Okay? Right. See, now let us go to the probability of an event. Probability of an event. We have to read this one. Probability function, or say it as probability of an event is number of elements in the favorable set by total number of elements in the sample space. Number of elements in the favorable set by total number of elements in the sample space. Total possible outcomes. Total possible outcomes. So this is the probability of an event. Classical definition of probability of an event. P of E. Suppose if you name the name of the event means favorable set. So number of elements in E by number of elements in sample space. And observe that probability of every event is lying between 0 to 1. 0 is included, 1 is included. So E is a part of sample space. Hence either numerator is smaller than denominator or both may be equal. Hence if you take whose ratio, this result would be 0 to 1. It may be 0 or 1 also included. So this is the classical definition of probability of an event. This is very, very important in this entire chapter. Okay, right. Now, let us take one example. Take a coin, throw it. So we may get either head or tail. Now let us say E be an event, otherwise you can say it as even, which represents getting head. E to be another event which represents getting tail. Now what is the probability of getting head? Means you would have to find P of E1. So number of elements in E1 by number of elements in sample space. Here how many are there? 1. Here how many are there? 2. 1 by 2. Now go to there. What about P of E2? So here number of elements in E2 by number of elements in S. So there are only one element is there by total 2 elements. 1 by 2. Both events are subset of sample space and both probability is same. So whenever this probability of an event is same, then such events are said to be equally likely events. What do we say them? Equally likely events. Okay? See, this is the sample space for throwing a coin. And these are two subsets of this. And their probability is same. Hence, so what do we say them? Equally likely events. Okay, probability, which is nothing but where do we use this probability? Just for the predictions. Okay, so for guessing. So that you can able to convert this probability of an event into the percentages. How much percentage we may get head, how much percentage we may get tail. So how do we get? After getting the probability, multiply with 100, so that these chances will convert into the percentages. Here you got 1 by 2. So multiply with 100, so that you will get 50%. How much percentage of head we may get? 50%. Even this one also you can convert into the percentages. Simply you multiply with 100, so that these chances converts into the percentages. Okay. Now is probability of getting an event 125%. Is this possible? Not possible, because if you remove the percentile symbol, so you will get 1 by 100. Now 25 fours are 25 fives are. So you get 5 by 4. So here, if you convert into the decimals, this is more than 1. Hence, this is not possible. So probability of an event is up to 100% only, or below that. 0 to 100% only possible. If the percentage is more, so that is okay, not represents probability of an event. Remember this point. See, next, suppose if you take the union of these two, E1 union E2, now you get sample space now. E1 represents getting head, E2 represents getting tail. Now take their union, you are getting sample space now. So if you get like this, then these two events are said to be exhaustive events. What do we say them? If the union of events is equal to sample space, then such events are said to be exhaustive events. Okay, students? Right. Now suppose if the intersection part is an empty set, E1 intersection E2, if this is empty, then E1 and E2 are said to be mutually exclusive events. Mutually exclusive events. Okay, students, if the intersection part of events is empty, then such events are known as mutually exclusive events. For example, previous events you can take. Okay, E1 there represents getting head, E2 represents getting tail. So there is no common part, no? Hence, that events are example for mutually exclusive events. Sometimes probability of an event may be 0. For example, I give you this 1, 2, 3, 4, 5, 6. So this is the sample space for throwing a dice. What is the probability of getting 7 when you throw a dice? Is this possible? Not possible, because we mentioned on the surface of the dice as 1 to 6 only. There is no 7. So if you throw on the floor on the topmost surface, is there any chances to get 7? No. So here event B is empty. Hence find whose probability? P of E. There is no element. Number of elements in E by number of elements in S. Number of elements in event 0 by 6. 0 by 6, which is equal to 0. So this is called an impossible event, because their probability is 0, no? If the probability is 0, then such event is called impossible event. Remember this. Sometimes probability of an event may be equal to 1. Shall I give you that example? So you can take this one only. Throwing a single dice. So see my question. Find the probability that getting 6 or less than 6 when you throw a single dice. Tell me. There is an event E which represents getting 6 or less than 6 when we throw a dice. So when you throw a dice, this is a sample space. Then what is an event? Getting 6 or less than 6. 6 or less than 6 means 1, 2, 3, 4, 5, 6. This is an event. Now find whose probability? P of E, which is equal to N of E by N of S. N of E means number of elements in the event, 6. By total number of elements, 6. Both of them cancel, result is 1. Whenever you get the probability of an event is 1, then such event is known as sure event. Sure event. This is also known as certain event. Sure event, that is also known as certain event. Okay? Right. Next, see. See, whenever E plus E bar is equal to 1, then E and E bar are called complementary events. So here write whose probability. See, P of E plus P of E bar. P of E plus P of E bar is equal to 1. Then such events are known as complementary events. Complementary events. Okay, students, where E represents happened, E bar represents not happened. E represents what? Happened. E bar represents not happened. For example, take this coin case only. We may get head or tail na. If E represents getting head, then obviously E bar will represent not getting head. Not getting head means what we may get? Tail. Now, what is the probability of getting head? 1 by 2. What is the probability of not getting head? Not getting head. Getting, not getting. Not getting head means we may get tail na 1 by 2. 1 by 2 plus 1 by 2, 1. So, whenever P of E plus P of E bar equal to 1, then E and E bar are called complementary events. Okay, now students, see, these are types of events. So based on this, you have many more applications in the introduction part also. For example, I give you one question. Answer it. What is the probability of getting 53 Sundays in a leap year? See, very good question. What is the probability of getting 53 Sundays in a leap year? Tell me, how do you answer to this question? You know, in a year there are 52 weeks, because if you take any day, either it may be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. In a week there are 7 days. Every day will repeat 52 times in a year. Hence we say in a year there are 52 weeks. So 52 into 7, if you multiply, so you will get 364 days. But in a leap year there are 364 days. 366 days minus 364 days. 2 days will be left. So here, what is our question? What is the probability of getting 53 Sundays? Means already here 52 Sundays are included. But still we want one Sunday extra. Where do we get that extra Sunday? Means that remaining 2 days. Here 364, but in a leap year there are 364. Subtract this from that, you get 2 na. These 2 days will be, okay, any 2 days. See, we may get that choice like this. See, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. So you get any one of these two, any one of these 7 cases. 1, 2, 3, 4, 5, 6, 7. There are 7 choices. 2 days remains, no? The remaining 2 days may be any one of these 7 pairs. Okay? But here already 52 Sundays are included. We want one Sunday. Where is that one Sunday? Either it is this one or this one. We have 2 possibilities. We may get the remaining 2 days. Either we may get this pair or this pair. In these 2 pairs, Sunday is included. Okay. So either it may come or this may come. Remaining 2 days. So this is the favorable to us. Favorable counts which have to be written in the numerator. Then total possibilities you have to write in the denominator. 2 by 7. Okay, is the required probability. Probability of getting 53 Sundays in a leap year. Not only Sunday. If you take any day in a leap year, how much possibility will be there? 2 by 7. Any day. But here I took Sunday. If it is a non-leap year will have 365 days. So subtract 365 minus 364. 1 day will be left. 1 day will be left means here already 52 Sundays are included. We want extra day. That extra day is remaining day. So that you will get 1 by 7. We have one day left. That one day may be any one of this Monday to Sunday. 7 choices. But we want a Sunday. So that you have to write favorable one in the numerator. In the non-leaf year, result is 1 by 7. Getting 53 Sundays is 1 by 7. In a leaf year, 2 by 7. So this kind of questions can be expected based on that basic probability. Like I ask you one more question. What is the probability of getting a red face card when you pick a card from the deck of cards? A student well shuffled deck of cards and he is picking a card from it. What is the probability of getting a red face card? You know. So in every shoot there are 3 face cards. In the deck, diamonds and reds, hearts are there with red color. So in both 3 face cards are there. Total 6 face cards. These are favorable. Any one of that red face card can be come out. And by total 52. Now simplify this. You will get 3 by 26 probability. Like many questions you can arise. See one more question. What is the probability of getting a doublet when you throw 2 dice on the floor? Doublet. A doublet means 2 dice you have thrown. So whichever outcome will come on the first one, same outcome should appear on the second one. So what are the possibilities means 1, 1, like 2, 2, like 3, 3, 4, 4, 5, 5, 6, 6. These are favorable counts which have to be written on the numerator. By total 36. So 6 1 is 6 6. 1 by 6. Favorable outcomes. 6 and total 36. 1 by 6 is the required probability. Getting doublet when we throw 2 dice on the floor. Like what is the probability of getting the sum of outcomes is more than 10 when you throw 2 dice. What is the probability of getting the sum of outcomes is more than 10 when you throw 2 dice? Means either we may get 6, 5, 5, 6 or 6, 6. Only 3 possibilities will be there. More than 10 I said to you. Okay. If you add total 36 outcomes will come now. I have shown you that sample space in which if you add the outcome sums, here it is 11, here it is 11, here it is 12. So total 3 possibilities which have to be written in the numerator and total 36 possibilities right in the denominator. So this kind of questions okay will be there in the basic probability. I hope you have understood this introduction part of basic probability. Okay, I have given you 2 or 3 small applications also based on this. When we go to the books, we find many more applications. Okay, in the future classes of this probability, I explain you many more applications. Okay, which appears in the competitive exams like MSET, mains and advanced level exam. In the second part of this probability class, I am going to give you the concept related to the addition theorem on probability, conditional probability, multiplication theorem on probability and Bayes theorem. Okay students, thank you one and all.